Right, so let's talk about ingot casting. There are two main types of ingot casting, one being the top pouring and the other being the bottom pouring. And the top pouring is the one that is most common because you would have seen that in a melt shop where you've got your operator, you've got your mold, and you have your operator just pouring hot iron into the mold. So it's quite common in various small tonnage shops. And then the other process is the bottom pouring, and that's safer and used for very large ingots. And so this is a diagram here showing the bottom pouring ingot process. We'll talk about this soon. So just like I said, we can decide to use either top pouring or bottom pouring depending on the nature of steel and depending on the tonnage required. Now let's look at bottom pouring. So the process is usually uphill tamed. So basically we've got the steel, still not yellow, is poured into the runner, and it goes in and then goes back up into the molds, and that's why it's called uphill taming or uphill tamed. And then the steel flows from the runner, or it flows from the runner into the spider over there, and then from the spider it goes into the cobble, and the cobble is this shape over here. I think it's magenta in color, and the function of the spider is to allow the feeding of the mold. So you've got the steel going in, and you've got about 7 molds in here, and from the cobble it flows uphill into the ingot mold. And this mold is mounted on a base plate over here, and these base plates help to extract heat from the melt to form a solid steel. So this is the ingot casting process. So let's examine ingot casting from a solidification point of view. And so this is just a cross section of the ingot as well, and the ingot mold. We've got the open cavity over here, we've got dendrites here, we've got pipe, which is like a defect in the center of the ingot, and we've got end segregation here as well. So like we mentioned previously, the walls of the ingot mold over here they help to extract heat from the melt, as well as the base plate. So we've got the base plate over here as well. Talked about this in the previous slide, and this also helps to absorb heat and gently cool the melt. And as heat absorption takes place, a solid shell is formed, and this grows at a time dependent rate. The next step is the formation of dendrites, which is over here, and these dendrites then sink to the bottom of the ingot. And because temperature drops further, the shell in the ingot thickens as well, and then solidified steel, which has a higher density than liquid steel, drops further to the bottom of the ingot, and then you've got the liquid steel in the center of the mold. Whilst all of this takes place, this leads to the formation of an open cavity at the top of the ingot, and we can control this open cavity by using a mold powder or an insulatory head. There's also a process called segregation, where elements or purer crystals, they migrate either to the center of the ingot or to the end of the ingot. So we've got end segregation, and we also have what we call center segregation as well. and we can control segregation by minimizing segregating elements or controlling the casting speed.